Alright, today's notes are on synthetic division. Goal: upon completion of these notes, students will be able to use synthetic division to divide polynomials, factor polynomials, and find zeros of polynomials. Remainder and factor theorem. This is going to seem a little complicated, but I'll clear it up in a minute. If x minus k is a factor of a polynomial, then x is a solution, or 0 or x-intercept of that polynomial, and the remainder when dividing the polynomial by x minus k, or that factor, will then be a 0. In other words, the x minus k divides evenly into the polynomial. Well, you recently did long division, so I'm going to use a quick long division problem to explain what that means. So let's say I divide 13 by 4. Alright, now if I divide 13 by 4, what's going to happen is you have 4 will go into 13 3 times. If I multiply 3 times 4, which is 12, and then I take 13 minus 12, I get 1. Well, here I do have a remainder, so this right here is my remainder. And so clearly what that means is 4 doesn't evenly divide into 13. And as a matter of fact, that means neither 4 nor 3 are factors of 13 because 4 times 3 is 12. Alright, now if I divide 4 into 12, then 4 does go into 12 3 times. 3 times 4 is 12, and 12 minus 12 is 0. Our remainder is 0. And what the factor theorem up there and the remainder theorem tells us then is that 4 went into 12 evenly, and not only that, 4 and 3 are both factors of 12. So I could write 4 times 3 equals 12. And so it's a way of factoring. Alright, so this problem here says use synthetic division to divide the polynomials. Now, synthetic division is a shortcut to long division, but it only works, and I'm going to put a 1 right here. See how that's x to the 1? This is very important. This factor right here, this one, has to be linear. So if this has an x squared minus 2 or anything other than an x to the first power, you can't do this process. Alright, now again, this really relates back to something else we've learned, zero product property. If x minus 2 would be a factor of that, 2 would be a solution to it. Alright, and so I'm going to put 2 right here. Another important thing is if the factor is x minus 2, I got to put the solution or would-be solution there, which is 2. Now this process is going to look a little weird at first, but we'll get used to it. Just make this little half a box that I made here. And what I'm going to do is a process, again, called synthetic division, where we just use coefficients and we don't use any of the variables. Now the other thing I have to be careful of here is I have an x cubed minus 7x minus 6. In descending order, you can notice that we're missing an x term. We're missing an x squared term. So I'm going to think of it like a 0x squared is kind of inside of here, like x cubed plus 0x squared minus 7x minus 6. And so when I write these, I need a placeholder for the 0. So I'm going to put a 1 for that coefficient. I'm going to put a 0, which is real important if you're missing a term, for the x squared, minus 7, and then minus 6. Alright, all we write down are the coefficients right in front of those numbers, and it's important that it's in descending order. Then this number right here is going to drop down, 1. 2 times 1, so we multiply here, 2 times 1, which is 2, and we add here, 0 plus 2 is 2, and we repeat the process. So 2 times 2 is 4, negative 7 plus 4 is negative 3, 2 times negative 3 is negative 6, and again we add this way. Negative 6 plus negative 6 is negative 12. Turns out this is our remainder. So if we were to do this by long division, all of these numbers right here would be on top of your division signs, or symbol, except you'd have variables with it. And your remainder here is kind of like this remainder down here. And so now to write the answer to this division problem, these coefficients that are right here are my new coefficients of my answer. And since we started out with this 3 right here, it's a cubed, and we literally divided by an x. A cubed divided by an x goes down to a squared. So we write a new polynomial with these highlighted numbers, 1x squared plus 2x minus 3. This is the answer to the division part. All right, we'll do this again in a second. All right, but we also have to write our remainder, which is plus negative 12, over our divisor, which is x minus 2. This is the final answer to the division problem. So I know this seems a little weird, but let me explain something a little better here. If you were to do the long division, the 1x squared, you would have this up here, 1x squared plus 2x minus 3. And way down the bottom, after you go through all the process, you'd have the negative 12 as the remainder. That's exactly how it would work out with a long division. It's just a shortcut. All right, let's move on to the next problem. Factor the polynomial given that f of k equals 0. In other words, we're giving you 1, 0, and you need to use it to factor the polynomial. So this is saying right here, another way of saying that this value after the semicolon, k equals 6, if I were to plug it into the polynomial, I would get 0 out, which then says that x equals 6 is a 0, or yet again, that means x minus 6, using zero product property, would be a factor. So we already know one factor of this polynomial. We want to use it to find the other factors. So I'm going to put the 6 right here, just like the last process. I'm going to make my little brackets here, or half a box, whatever you want to call it. And notice I have cubed, a squared, an x, and a constant, so I do not need to have a placeholder for zeros. So there's a 1 here. I'm going to write a 1 here, just the coefficients. I have a negative 3. I have a negative 16. And a negative 12. All right, just like before, this 1 gets dropped down here. 6 times 1 is 6. Negative 3 plus 6 is 3. 6 times 3 is 18. Negative 16 plus 18 is 2. 6 times 2 is 12. And I absolutely should have expected that to be a 0, because we told you this was a solution. So we knew x minus 6 divided evenly, and the factor theorem is met. So what that tells me further is, first of all, x minus 6 from over here is a factor. Remember, we're going from a solution, which is 6, down to x minus 6 is factor, opposite. All right, these three values right here are going to give us the coefficients of our new polynomial, or the part that we divided to get our answer. We started out with a cubed, and so now again we go down by 1 power, which is a squared, and we use these numbers highlighted as my coefficients right in order. 1x squared plus 3x plus 2. Now I'm going to factor this further like we always do. So f of x equals x minus 6. Now, since there's a 1x squared, I'm simply looking for numbers that multiply to 2 and add to 3, which are x plus 1 and x plus 2. And so that is completely factored, and this problem is finished. All right, so I knew the fact that 6 was a solution, and I used that to factor the rest of the polynomial. All right, let's do the next one. Now the directions here change a little bit. Given 1, 0 the polynomial, find the remaining zeros. So this is our third goal. All right, again, we have a different notation here. Right here, 4. That means we know that 4 is a solution, which then means that x minus 4 is a factor. So we're going to start this problem right away and put a 4 right here. And again, I do not take the opposite of that 4 unless I'm writing it as a factor. I have 2x cubed, 3x squared, negative 39x minus 20. I do not need a placeholder for any zeros or missing terms. So 2, 3, negative 39, just the coefficients, negative 20, Alright, I'm going to drop down this 2. This number always drops down. We multiply this 4 times this 2 to get the 8. 3 plus the 8 is 11. 4 times the 11 is 44. Negative 39 plus 44 is 5. 4 times 5 is 20. And once again, this better be a 0 here because we started out knowing 4 was the solution. I'll go ahead and write this over here. Actually, let's start out here. F of x equals, now I'm writing the factors, x minus 4 because this is a plus 4. These 3 numbers, I'm not going to highlight them this time, but our remainder is 0. So I know this is kind of like the 4 times the 3 from the example before, the 12. So 2x squared, again down to a squared because I started out with a cubed, plus 11x, just right in order, I'm using these numbers right here, plus 5. Now I got to see if that factors further. Now I'm going to factor this pretty quickly because we have factored many things before. So now a 2 will not come out. I can't factor out a GCF. So I put a 2x here, an x here. I don't have many choices for that. And then really the only numbers that multiply to 5 are the 1 and the 5. I just got to figure out how or if they work. And so this is one of those factoring problems where I got to make these 2 multiply and these 2 multiply, and those add up to the middle. So if I put the 5 over here, I know that gives me the 10x. And if I put the 1 here, that gives me 1x. And 10x plus 1x is 11x. So that's factored. Alright, but this says to find the remaining zeros. Alright, so I have to keep going and set each piece equal to 0. Now, x equals 4 is already a solution. I'm going to just write that here. We already knew that. So I don't really have to solve that part. X minus 4 equals 0. Already we know that's a solution. But I'll do the other pieces. So 2x plus 1 equals 0. This is zero product property. So 2x equals, subtract the 1, negative 1, divide by the 2, x is negative 1/2. So I have that solution and one more. X plus 5 equals 0. Subtract the 5 and x equals negative 5. So I get this solution, and that solution. Alright, now keep in mind we've talked about this in class. Here I have a cubic, right? Well, I should expect at most 3 real solutions, and I have all 3 of them. Alright, now I'm going to save B for us to do in class, so we'll do that in class together. And I want to talk about this last question here. In example 3A, and B we'll actually do in class, so you can really just focus on A. We gave you 1 0 or solution. If you had your calculator available to you, specifically how could you find a 0 on your own so you could solve the problem without someone giving you a 0 to get started? Have your replies ready for class. So what I'm saying is, up here, right here, we gave you this solution. I could not have started this process with this 4 right here had I not already given you that solution. Alright? So how could anyone start a problem like this and solve it if I don't give you a solution? But remember, and here's a hint to it, you have your calculator available to you. Alright? So have some ideas in class. We'll talk about this next time we meet. Alright?